Trying out a new way of making slides. If you don't like it, let me know. But it turns out you can turn your Jupyter notebook into a slideshow. So I wanted to try it out. So today we're going to talk about something pretty cool. I think it's a fun topic. It's called Internet I/O. If the font is too small, you don't see. I put the slides up online right now, so they should be down here on the course website. So you'll have everything I'm going to be doing right here. Okay, I suggest you can try following along actually, it should be fun. All right, before we do that, assignment 3 is out. I recommend you guys start on that like as soon as you can. This one has more parts and might take a little more getting down to business. So it's not super complicated. I think it's a pretty cool topic. One of my favorite topics is evolution. So the idea is you're going to be creating your own little evolution simulator. The idea is that you want some sort of population of cells or whatever you want to evolve and improve on their own. And so you're going to simulate the entire process from creating a population of molecules and seeing how fit they are, from doing natural selection on them to reproducing and mutations. And you'll see, that your populations are going to improve. There's some background, and at the end there's just a little bit of plotting. So you practice your basic, how to make some basic plots like Chris was talking about, like line plots, histograms, and heat maps, things like that. So it's not very complex, but it is more like independent coding. So there'll be blocks where you just have to code for a while. So I suggest you get started, make sure you understand it. If you have any questions, please let us know right away. The download information is on the course website. You just have to click download on the link. And there's another file you have to download. No installing, just another file you have to download from the internet, and then you're done. Okay? So it's going to be due in 2 weeks from now. So it's been out since this morning, so if you had a head start, that's fine. It's due on Monday, November 13th at 11:59 p.m. Okay? And midterms have been graded. The grades will be out in the next day or two. We just have to make sure everything's okay and finalize everything, put the grades in. And unfortunately, I don't think we're going to be able to let you keep the exams. So whenever you want to have a look at them, just come to office hours, either mine or Chris's office hours. Maybe the TA's, I'm not sure yet. And if you can't make it to office hours, just make an appointment and we'll sit down with you and go through your exam. It's very important that you understand all the concepts that were covered in this midterm moving forward so that you're not lost at the final or lost at the subsequent assignments. So yeah, make sure you have a look at your midterm. I think most people did pretty okay. We're pretty pleased. So yeah, come to office hours. Okay, so today we're going to talk about the internet and how you can use it through Python, okay? So before we do that, I'm going to give a quick overview on what the internet actually is. Once we do that, we'll talk about how Python comes into it. And so yeah, what is the internet? This is a picture from a textbook from the 90s about what the internet was. Pretty cool. And I don't know if anybody relates to this this joke. I mean, I think I'm a little bit older than you guys, but when I was little, either you use the phone or you use the internet because they were going through the same connection. So it was like, hang up the phone, I gotta go on Hotmail or something, So it's come a long way, and it's actually a super powerful tool, as you probably know. And we can do really cool things with it now that we know a bit about Python. So basically, the internet is just a network of connected computers, okay? Like this computer, it's all just computers with files on them, okay? And basically, these computers can talk to each other. So it's like if you're on Facebook Messenger, you can send a message to another computer, okay? And they're literally connected by cables, right? There's cables that go, from the bottom of the ocean to Europe and connect Europe and America, and then there's wireless communications. But basically, it's all these computers that are all connected to each other that know where every other computer is, and basically they can talk to each other, and in the end, they just ask each other for information, okay? And information, as we saw, basically is just a text file, basically for us, okay? It's just some text, right? So they say the internet, kind of the way we know it now, started out in 1989. when this guy called Tim Berners-Lee invented something called the World Wide Web. So basically, what he did and what other work from people did was they established some sort of set of rules or guidelines for when two computers are talking to each other to make sure that they're always speaking the same language. That language is called TCP/IP, Transfer Control Protocol over Internet Protocol. These are just background details, you don't have to worry about it. But basically, it's just some sort of format guide that, when I connect to a computer, I'll know what type of format that they're going to give me, and they'll know what type of format I'm going to give them. So it just makes sure everyone's sort of speaking the same language, okay? And that's what became known as the World Wide Web. So basically, the World Wide Web is a bunch of computers. They each have an address. You've probably heard of like an IP address, right? It's just a number that's kind of like your home address, and that's where people can send you messages, or you can send messages to other people, right? Kind of looks something like this. A lot more complicated in real life, but you have two major components that we're going to talk about, okay? There's the client, and then there's the server. All of these things are still just computers, but they just have different names. So typically when we interact with the internet, we're what's known as clients. So we want some information from some other computer, which happens to be called a server. So when you log on to Facebook, Facebook has these big computers. At the end of the day, they're just computers that are called servers, and they're just always on. And they have some address that has a nickname, which is facebook.com. So Facebook has some IP address, which is like 135.67 whatever. But when you type it on your browser, it actually gets converted into, when you type facebook.com, they know which address that's mapped to. Okay, so that's called a domain name. And basically, from my computer, which is the client, I send a message to facebook.com saying I want my pictures from last year. Send that message. Facebook is a server, so what it does is it serves that information. It says, oh yeah, I have that file stored. I'll spit it back out to you, and over the wires, it comes back to your computer, and your browser converts it into a pretty picture, with all the buttons and everything that you can see and click on and all that stuff. But yeah, that's basically it. There's clients and there's servers, okay? Clients request information, and sometimes they also present information to the server, right? Let's say I want to make a tweet. I send the server a message saying, store this on your server, right? So that other people can then request it and see it, right? So that's kind of the basic scheme, right? And this big cloud in the middle is just a bunch of other layers that, make sure that your message is getting sent to the right person. And there's other computers in there and other servers. But for us, this is typically all you really care about. If you're interested in this kind of thing, there's a course called Comp 206, which focuses more on this kind of topic. But for now, this is just kind of like a cool little tutorial. So servers fulfill requests from clients, right? Clients are computers that ask a server for information. So for example, right, like I said, you connect to Google. You send your URL to the IP address of Google, and then Google receives it and sends you back whatever it interpreted as the call from that URL, okay? So Python lets us kind of get into this world in a really cool way. Normally, when we send these requests to servers, like we go on a website and we click on a button, and our browser turns that button into like an actual message to send to the server, right? But sometimes we can do better than that. We can use Python to automate things, right? That's basically the whole point of programming, is to make things automatic. So you can make these requests automatically to the server. So let's say you want to, I don't know, spam Facebook, with some party you're going to throw. Like, you can write a little Python program to like send out requests, automatically to everyone or something like that. Or let's say you're really interested in obtaining some sort of data from a website. You can automatically download their entire data set or filter it out however you want. So it saves you time from clicking on stuff, right? So that's where Python comes in automating things, okay? Automating the way we connect to servers. And the way we actually talk to servers is through something called a web API. So an API is an application process interface. I'm not sure what the P stands for, but something, application and then interface. Not important. The point is the server basically writes a bunch of functions, like we've done in Python already, that do stuff, all right? And they make the documentation on how to use those functions publicly available. So I can go on Twitter and look up what their API is. And what their API is going to be like the Python documentation we've seen, but for Twitter. And it'll have a function that says, if you call this function, it'll post a tweet. Or if you call this function, it'll download all the tweets with a specific hashtag or something like that. Okay? So that's called an API. It's just a set of functions that are implemented by the server, which a client can then use to interact with the server in a really convenient way. And there's two major ways that we can use this API. Like I already hinted at, either we can receive data from the server, so we can request all the hashtags, I don't know, TGIF hashtags from Twitter. So that would be called doing the get method from the server, which means I want to get information from the server. Or let's say I want to tweet a picture of my dog, I would use something called a put. So I want to put data on the server, okay? So these are the two modes that we're going to be exploring here. And basically, this lets us programmatically, so writing Python scripts with loops and functions and variables that obviously are super useful if you want to do things automatically. Instead of having to click through browser buttons and dealing with files on your computer and all that stuff, it just makes everything a lot faster. The other cool thing is that, man, this font's really small, I'm sorry. I hope you guys can all download it on your side. So, for example, a lot of these websites now and all of these web services have a huge amount of information on them and a huge amount of data. For example, Twitter is like, I don't know, millions and millions of gigabytes of information that's stored on their computers. And, you know, if you want to access that data, right, you want to do some study on, like, I don't know, try to predict the winner of an election based on people's tweets or something like that, and you want to use that data, you don't want to have the entire huge data set on your computer to actually play with it. Sometimes you just want to have a quick, convenient way for somebody else to store all of the huge data set, but you just want to make requests for something that you're more like interested in specifically. Okay, so that's another important use of servers, is that we can request small pieces of data, right, from a large data set that's stored in a huge computer somewhere that's super expensive, and still do something useful with that information without having to store everything ourselves. So, we're going to talk about a module in Python that makes all of this super easy for us. It's called the request module, okay? And basically, the name speaks for itself. It lets us make requests to the server really easily, okay? And it also lets us receive requests from the server at the same time. Sorry, not receive requests, but receive the output of a request. This is not installed by default, but you can quickly install it on your command line or terminal by writing conda install requests. And that should install the library for you. And then you can use it, play around with it. And then all you have to do to use it in your code is to import it. So I'm going to import it. Okay, so I import it. All right. So now I can make use of this. We're going to use two APIs today, but there's like thousands, and I have links on more details on other ones that you might be interested in, but a really simple one that's kind of a good starter is called the International Space Station API. So NASA has a web server that is constantly tracking where the International Space Station is and some information about it. And you can use Python to make requests to the server and get data on the International Space Station like live in real time, okay? So depending on what type of data you want to access, for example, we're gonna access three types of data. We're gonna find out where the space station is at this moment, how many astronauts are on the space station right now, and when is the next time the space station is going to fly over Montreal, okay? So these are three different types of questions we want to ask the server, and basically they correspond to three different API endpoints, is what they're called. Okay, so it's just a part of the API's code that does a specific function, okay? We'll see exactly what they look like later on. Okay? And basically the way you talk to a website is through the URL string. I don't know if you notice, like when you click on stuff and on your browser, you get this huge like long string with a bunch of like random looking stuff. That's actually the information that the server receives and interprets in order to send back to you the correct information, right? Like if I go on, not GoDaddy, I go on Google and I say cats, maybe we can interpret this a little bit. So I'm saying, damn it. Okay, you guys can do it on your computer. But basically what's happening is, this is the information that Google sees, okay? So your browser, after you typed in cats, it converted that into this crazy huge string, okay? And so HTTPS is called the Hypertext Transfer Protocol, which is kind of the language that the server and the client are going to talk to each other, right? It's just a set of rules saying when I receive some data, I expect it to look as outlined by the Hypertext Transfer Protocol. Don't worry about it. And then I say, all right, where's this server? It's at www.google.ca, which in reality is some IP address that Google can map to, okay? And then I have a bunch of other information. So we can start to like sort of decode it. I mean, you see search, so maybe it's telling the server that I want to do a search, right? And okay, this other stuff I don't know about. But then you see something like, for example, Q equals cats, all right? So that's saying Q probably stands for query, so what's my query? And equals is cats, okay? So we're starting to see a little bit how these APIs work, is basically the server will understand this string, just like a Python function call, right? When you give it arguments and it returns some value based on those arguments, the API works the same way. It's just that information on how you call the function is encoded in the URL string, all right? So what the request module does is it builds these strings for us conveniently, so we don't have to like do a bunch of string manipulations, and it is also able to send it along without us having to worry about any of the nitty-gritty stuff. All right. So the first thing we're going to do is get some information from this API, all right? And let's open it up here. So this is what's called the front end, so what the user sees. And it has three endpoints, right? Current location of the space station, overhead pass prediction, so when it's going to pass overhead, how number of people are in space, all right? So you can click on this, and it'll tell us how to use this API, all right? And basically it tells us this URL, just like the google.com, is the one that we want to send out our requests to, all right? issnow.json, all right? So let's try it out real quick. So this is what I'm doing here. Basically, I define some string. It's this URL that was on the other page is api.opennotify.org. So I just want to give that a name, call it base URL, right? So all the other API calls are going to contain that string, so we just conveniently give it a name. And then we're going to use our requests module, right? And we're going to use its function called get, right? So this requests object is going to get us some information from the server based on some URL string, right? Just like we saw with Google. So it's going to just be, I'm going to concatenate the base URL with the rest that was on the documentation, which was issnow.json, which stands for International Space Station Now.json, right? .json is saying that the format we're going to receive is a JSON object, which Chris talked about briefly. We're going to look at it again. So this should actually send a request to the server, okay? When I hit enter on this.
So
yeah.
You always have to specify the text format, the defined format.
It depends on the API. So this is just an ending. It depends on the API. Some will have this, some will not. But usually it'll give you some information of the formats that you're going to receive. Yeah. It just really depends. You just have to look at the documentation. I don't think this is mandatory at all. Okay, so what this did was it took our URL, it built it, and it, as though we had typed it in on the browser and hit enter, well, now we're doing the same thing but in Python, okay? Without having to open Chrome and type stuff in, boom, one line. All right, so that should have sent it out to the internet and it should have come back, all right? And now we have this object, right? So we stored whatever, this returns something called a response object, right? So we send a request to the server and the server responds. And the library request stores it as something called a response object, okay? Which is going to have some useful information about what the server said back to us. So I'm gonna print out. Let's print them on one at a time here. Okay. Okay. So the first, it has some useful attributes. They're in the slides too. So we did that. These are the attributes we're going to look at. Okay. Status code, content, URL, and headers. All right. Headers we can kind of forget about for now. But so the attribute URL is going to be the URL that actually like got sent to the server. Okay. So if we wanted, we could actually just click this, and we should see some output, right? Oh, starting to look nice. Okay. So that's the URL that response built and sent to the browser. All right. Just so we know for future reference. We can also print dot status code. Code, I hope is like that. Yeah. Okay. So this is sort of a diagnostic of what happened. All right. You see that it's the number 200. It means that the request was successful. So I formatted everything properly. The server was not down. It sent back a correctly formatted request. Everything went nicely. You see a 400. If I wanted to get a different code, maybe I would like make a typo here. Okay, now what? Okay, so I wasn't even able to connect. Maybe I'll make a typo here actually. I'll say I don't put in the JSON. Okay, so it's sending this request to the server, right? I guess because if you put the URL wrong, it just won't even be able to connect to the server. But now let's say I forgot the .json. Let's see what my response code is. 200. What? That's weird. Screw it up even more. Okay, 404. So now the status code changed. And you've probably seen this already like on the regular browser, but 404 means it wasn't able to connect to the server, right? And there's a bunch of other codes. You can Google them, but we'll just worry about hoping to see a 200 there, which means everything went well. Okay, so let's correct this now. Let's correct this. Okay. Hopefully we'll see a 200 again. All right, we have a 200. So the request went through, we got a response, and now let's see what actually we received. And that's called response.content. Okay. So we got the URL, we got the status of our request, and now we actually got what we care about, which is the content of that response. So we asked the server for the current position of the International Space Station by going to issnow.json, and it spat back something that looks like a dictionary, right? And it says, all right, it said this was a successful call. It gives us a timestamp, so when that happened, and this other key ISS position, which has the longitude and the latitude and coordinates of the space station at this moment. Okay. So that's pretty nice. Now let's say we want to actually use this response. Like let's say I wanted to print a nice string that says the space station is currently at this longitude and this latitude. Well, I'm going to have to actually index or access this thing that looks like a dictionary, right? Let me print out its type. It turns out that its type is a bytes string. So you can see this little quote mark and this B here means this is a byte string. So it's kind of like a string, just slightly different format, meaning it's not really a dictionary yet, but we can convert it to a dictionary because we know that this is in the JSON format. JSON format is basically a dictionary in a text file, all right? So we say we have this nice library in Python, the JSON library, which can convert things to dictionaries. So all we have to do is say response.json, right? That worked. And now it's converted that response, which used to be a string, into a dictionary. So now we can actually access it much more conveniently. Like for example, let's say I do it later. Okay. So I put together this string saying, the space station is currently at, and then R, which was my response that I converted to a dictionary, and I give it the key ISS position. And Whoop. Okay, so it says the current space station is currently at this longitude and this latitude. So we were actually able to take our response object, which was originally a string, we converted it to a dictionary, and then we accessed its position. All right? Any questions? All right. So that was pretty cool. Okay. So now we can actually, like, I don't know, if you wanted to write a program that like keeps you up to date on where the space station is at all times, now you have the tools to do it, right? You just have to send these requests in some kind of for loop or whatever, and you're good to go. Okay. I mean, so this was cool, but I mean, we can do something cooler, right? Because we basically always get the same data, right? We just get whatever the space station's location is at this moment. But the API can let us do cooler things. Specifically, we can actually pass arguments to these functions, just like we did in Python, right? Imagine all the Python functions we wrote never took any arguments, right? They would always behave the same. They wouldn't be super interesting. Like, yeah, so we can do the same thing with APIs. And that's basically using this key called params, which in your request adds some parameters to your API request. So like we saw with Google, we saw like q equals cat. That was a parameter. That means we want to do a search, but we specifically want to do a search for dogs, right? So it's a parameter that we're switching that we have control over, okay? So if we wanted to say, for example, when the ISS station is going to pass over Montreal, we would have to specify, well, where's Montreal, right? And since the website knows the location of the space station at all times, it'll just compare that to whatever coordinates we give it, okay? So now we have to use a different endpoint, which is just kind of like a different URL that we have to access. Before we were accessing ISS now, which spat back to us the current location. Now we want to use a different function that they implemented called ISS pass, which is when's the ISS station going to pass over a specific location, all right? So what we do is we have some parameters, right? We need to specify what location we want to know about. And the way all of these communications usually work is through dictionaries. So if you want your parameters, you put them in a dictionary, okay? And the dictionary is always a key and a value. So Montreal's latitude happens to be 45 degrees north, I guess. And the longitude is 73 degrees west, which it converts to a negative sign. So if you're west of, I don't know, some line, then you're negative. If you're east, you're positive. So Montreal is 45 and minus 73. I just Googled that. Don't know it by heart. Okay. So now we can just use our handy function here, request.get again, right? Because we just want to get information from the server again. And we pass our base URL, which was just like that, you know, where the server is located. And we add our endpoint, which is isspass.json, right? When we access this, it's going to tell us when the ISS station is going to pass over whatever location we give it. And then, because we need to specify which city we want to get information about, we have to use this other keyword argument from the function get, which is params, right, for parameters. And then we just set that equal to our dictionary that we had up here, which specifies the latitude and longitude we want. You could pick whatever latitude and longitude you want. So this should send a request, right? That looks a little more interesting than the previous one. So it should have sent it. And let's see if it was successful. Okay, so the status code is 200. Everything went smoothly. And let's see what the URL actually looks like. Okay, so what this request function did is it strung together this huge string here, right? That looked a lot like that Google URL we saw, right? Where it was like, okay, we want to access isspass.json, and we pass the parameters. Latitude is 45, and longitude is minus 73. Okay, so now when the server from the space station receives this string, they'll know, oh, I need to go look at latitude 45 and longitude 73, and then send back the correct output, all right? And when we look at what we actually received, we get this big weird thing. Again, it's some sort of string representation of a dictionary, so that should hint that it should be some sort of JSON object, and also because we're accessing a JSON API. And then let's convert everything to JSON. So now we have a dictionary, right? And we have some keys, again, like our message. We had a successful request. And then request summarizes what we asked for. So it just repeats that we asked for this latitude and this longitude. Passes is some sort of default that says, give me the next 5 times the space station is going to fly over. Apparently, like it goes super fast, so it's like many times. I didn't know that. And then finally, we have another key for the response. So what we actually want to know is when it's going to pass by. And that key maps to, right, with the colon, to a list, right? You see the square brackets? We have a list here, right? And what's inside the list? Well, let's look. Okay, this is the first item. First item is a dictionary, okay? And it says duration 369 and rise time this huge number. This is just weird formatting for how long the space station is going to spend above us. And rise time is the actual time stamp that it's going to pass, which is in a format called Unix time format. Don't need to know about it, but basically it's just a universal way of knowing what time it is, which we can convert to a regular time. So we'll see. All right, so we got our response. We got the data back from the server. Really nice. We got 5 of these because we asked for 5. 5 passes. So these are the next 5 times the space station is going to pass. And what we do then is, since we got a list, right? We got a list here inside the response key of the dictionary. We saw that we have a list, and the list represents 1 item for each pass that the space station is going to make above our heads. So we want to look at each item in this list and print out nicely what the time would be. All right? And this is what I do here. So basically, I import the module datetime, which you guys are all probably painfully familiar with. And super useful, though. So we're going to go for every item in this response, right? Which is just a list. And we're going to use the response to convert from a timestamp, which is this big number here, to a normal time, okay? And we pass it the key rise time, okay? This time format is actually used a lot in computers. It's how computers keep track of time. It's called Unix time. And it's basically just the number of seconds that have elapsed since midnight on January 1st, 1970. Okay? So that's just every computer in the world keeps track of this time for some reason. And since everybody agreed to use this time as a reference, then we can just count the number of seconds that have passed since that time. And then we can all have a common way of looking at time. Obviously, computers prefer that more than humans. So if I run this, okay, I get this list of times, right? So it looks like it passes about every hour above our heads. This is the date, this is the time. So yeah. Not bad, eh? It's pretty cool. Okay. So yeah, so now we talked to the server and we actually specified some parameters that we can play around with, right? We can, I don't know, pick your favorite city, look up its location, and I don't know, if you're a super nerd, you'll keep track of like when the space station's over your head. The last one, kind of a quick, easy one, is figuring out how many astronauts there are in space right now. That's another API endpoint, which is called astros.json. So again, you just give the get function the URL of the server, and you append to it this endpoint that you want to access, astros.json, and it takes one step, right? I get the request back, which I give the name astronauts. I convert it to JSON. I use JSON to convert it to a dictionary. And if I print it out, it should say there's 6 astronauts right now. And it should say, there's this guy, Sergei Ryaz, Randy Bresnik, Alexander Misur. All these people are right now in space. All right? And if ever one of them falls out of space or whatever, this dictionary will change. So that's good for us to know. All right. Any questions for that? So the reason we want to talk about these is because since you guys are all in science, most data sets, a lot of major data sets are available as APIs. So if you're interested in genomic data or some huge psychology study or some big survey or whatever, any of these big data sets are hosted or on a server that implements this API that lets you talk to it really easily and get the information you need like super efficiently. Okay, so I put in some links to like some random ones that are cool. Like Spotify has one, Reddit, SoundCloud, so you can get information about the website, the data that the website collects. Amazon has a really big one. There's a weather one, so you can get information about the weather, like with Python. NASA we sort of used already. And there's a bunch of like scientific ones, probably less boring for more boring for demonstration, but there's tons and tons. So if ever you have a project, think to use an API. Okay. So yeah, any questions? Sort of clear? Okay. I think we have time to get into this, but if not, we'll finish tomorrow, Wednesday. So basically, this whole time we've been getting information from the server, right? The server kind of stayed the same. All it did was spit out some data for us, and that was really cool. But we can also send requests for the server to update its data if it lets us, right? So often, when we put a picture on Instagram or we send a message on Facebook or whatever, these are post requests, right? Because we're telling the server, here's this information that I'm giving you, put it on your server, and then that way other people can pull it and access it, right? So if I post a picture, right, then it's on the server because I made a post request, and now someone else can make a get request and look at that picture on their computer, right? So I tried a bunch of APIs for this. I tried the Instagram one, but it had a bunch of permissions that were annoying. So I'm doing this example with Twitter API, which is a little bit easier to use. So the reason a lot of these APIs are sometimes a little annoying to use is because they really want to like kind of be tight on how you use their API, right? Because at least the really big ones, like the space station, I don't think anybody's like using it too much, but Twitter and all these, you can take down their server if you make 1 million requests per second. The server won't be able to handle that many requests at the same time, and it'll crash, and then nobody can use it. So usually what these big APIs ask you to do is register with them. You give them your email address, you make an account, and then if they notice that you're abusing their API, then they'll block you out, and then it sucks for you. You just have to make a new account and try again. A lot of them charge, right? So it's super valuable to have this data. Like, basically nowadays data is like super monetized. So having an API, people would pay for that information, right? So the server wants to know who's using the data and maybe charge you some money for it. So on Twitter, I had to use my account and tell them I wanted to use their API. What they did was they sent me a little a string, which was like some random combination of letters and numbers, which was my key to access their API. So every time I make a request to their server, I had to attach to it that key that says, okay, this key we've approved for use, so we can fulfill the request to them. Or this key is already done 500 requests this hour, we're going to block them because they're overusing our API, right? So you can look into how this works. It's called authentication. But I kind of hid that in the background because it's not super interesting. So yeah, what we're going to try to do is make a Twitter post. All right, so from Python, post a tweet on my Twitter. Okay. So I wrote a little module that takes care of this whole authentication thing. So it has the key that I got when I created an account on Twitter, and it just sends it to this object. I also didn't want to have the code here because if you saw it, you could abuse my API rights, and that wouldn't be fun for me. So assume that all the correct API permissions are given by this string. Okay, and now we can use the API sort of normally as before. Okay, but before we do that, let's just warm up a little bit and do a simple GET request. So I went on the documentation and I figured out what the URL I needed to use to get some information from Twitter was, and it turns out that it's this string called api.twitter.com. All right, so that's where their server that sends out API requests is located. And I had some search parameters. So I was interested in searching for some tweets that had some specific properties. So like before, I stored in a dictionary. And like we saw actually in the Google example, this Q key often stands for query. So I was trying to look for tweets that are about pizza. And I can also specify something called result type, which I set to recent, meaning give me recent tweets. So maybe the last, today's tweets about pizza, and how many of those do I want to get back? And I just said 2, all right? So these were my parameters. Just like before, we gave the coordinates of the location we wanted to know about the space station before. Now we're just going to say, look, we want to search Twitter with these keywords, right? So we're using our handy f strings here to make our URL. So basically, I give my base URL, and this is the endpoint. It's called tweets.json, all right? So I just stick them together, and this should be the URL that I want to use for my request, all right? And then I have my get call. Remember, I give the URL we built here, which points to the tweets endpoint, and I pass in this keyword argument that has my authentication information. So Twitter looks at that and says, okay, this is a valid user, so I'm going to send him some data. And then here I pass my dictionary with parameters, right? So let's hopefully pray that works. Okay. So let's print the URL and the status code. All right. So we're seeing status code of 200. That's good. It means it went through. And let's see the URL that it actually used. So as you can see, it would have been annoying to build this by hand. So I went to the tweets.json. Arguments or parameters are separated by question marks, you'll see. So the first one I gave was Q equals pizza. And this one does it by ampersands. Okay. And result type equals R, which I guess it abbreviated. It continues to recent. And the count equals 2. So this is really just like a normal Python function call, right? It's just that we're doing it over the internet. Okay. So if that worked, now we should be able to see information about these tweets that the server sent back to me. So I convert it to JSON. I convert the response to JSON. And then I accessed, so it gives me a list of tweets, right? Because I wanted 2 tweets, so it puts them in a list. And I want to look at the field in that tweet called statuses, so that contains the text. Maybe if I print the response, you'll see search response dot content. You'll see it's kind of ugly. It's like this huge thing just for 2 tweets, like so much information about it. But I went in and turns out all you really need is to access this statuses key, and then within that status you can access the text field. So again, these are all just dictionaries, so you can just look for the keys and access them the way you want. And I'm just going to print for each one. I'm going to print its text key. Okay, so these are the 2 tweets about pizza that it gave me. That's not a bad one. When your roommate eats all the pizza. Okay. So we were able to do a get. Now the fun one is going to be posting a tweet. So instead of using get, now we need to post, right? Because it's not the same thing anymore. We're actually going to give the server some information to store. Here are the parameters. Again, we need to pass what our tweet is going to contain. So that's in a field called status. All of this is in the documentation. So you just look it up and see what you need to use. So I make my dictionary and I say, hi from comp364, hashtag I am a god, because this is crazy that you can do this. And then, okay, so our URL is this. I Googled it. This is the URL I need to use to make posts to Twitter, all right? So then again, I use request library and I say .post. I pass my URL. I give my authentication. I give the parameters, and that should send out a tweet. 200, okay. So if it worked, if you go on my Twitter, we should see a tweet. Hey, there you go. Very cool. Very cool. Okay. So that just saved us a lot of clicking, right? Very cool. Okay. Yeah, that's pretty much it, actually. If you have any questions, we have 4 minutes. All good? Okay, so yeah, feel free to play around with all these APIs. It's pretty fun. Get blocked out. Who cares? And yeah, we'll see you guys Wednesday. Hopefully the midterm grades will be out before then. and you can come to office hours and get started on the assignment, please. Okay, thanks.